Okay, so we've got a vectors question here. Usually these are quite hard, aren't they? And they come at the end of the paper. What I'm going to do is I'm going to describe how to get from A to M in two different ways. Now, the easiest way is we'll start off with what they told us, that A to P is this 3.5 A's plus 3/4 B's. Okay, and of course, if I just carry on that straight line AP, some extension of it. Now I don't know how many times longer AP is than AM. That's what I'm trying to find, isn't it? This K. Um, but I can write down how to get from A to M is like this. Okay. So 1.5 K A's plus 3/4 K's B's. Okay. So that's one way of getting from A to M. But we could also go from A to B and then B to M. And this is and that's the same journey, isn't it? So we've described the same journey in two different ways. We can then have a sort of simultaneous equation and work out the value of K, and then we can answer the question. So A to M is going to be A to B plus B to M, and B to M is some fraction, a different fraction from K, some M fraction of the journey from B to C. I hope you agree that if you start at B and you travel towards C, if you, let's say, half the journey, you might get to M. So here I go, I'm describing A to M in this route, A to B plus B to M. So A to B is what? That's plus 4A, isn't it? Okay. Yeah, A to M is 4A. So from A, I'm going from A to B, and then I'm going to go from B to C. B to halfway, some fraction of the journey, B to C. So A to B is what? That's from our diagram. A to B is 4A. Okay, so just check the diagram if you can't remember. A to B was a journey of 4A. Okay. It should be positive 4A. I hope I'm going to correct myself. Yes. Good. Okay, and then some fraction of the journey B to C. Okay, which I'm calling B to M. Now I can tidy that up a little bit. So A to M is going to equal 4A's minus 4MA's plus 2MB's. Alright, and I can tidy that up even further. I can factorise out the A direction vector, which is going to be 4 minus 4M. Alright, and I can't do anything with the B one. So now I've managed to describe the journey from A to M in two different ways, going directly and going round the long way. Okay, so I'll write down what I've discovered. A to M is both some multiple of the journey A to P and what I've also just discovered, it can also be written as 1 minus M lots of A's and 2M lots of B's. So because these are the same vector, then that means that 3 over 2k must be the same number as 4 minus 4m. They've got the same A coefficients. And 3/4 of a k must be the same thing as 2m. Because they're both the same vector, A to M. Now what this means is that I can solve and find a value for k and m. K is really the one I want. Okay. So if I times through by 2 to get rid of that horrible fraction, 3k equals 8 brackets 1 minus m And if I times this on by 4, I get 3k is equal to 8m. Now I can see I've got two equations both equal to 3k, which means that 8 minus 8m must equal 8m. So we should be able to solve for m. And that's going to give me what? 8 is equal to 16m. Okay, I'm writing out in full, that's good. Okay, so 8 is equal to 16m. And therefore m is equal to a half. And I can use my 3/4 k equals 2m. 2 times by a half is 1. That means that 3/4 of the k equals 1, so the k has to equal 4/3, doesn't it? So I've managed to find the values of m and k. So now I can describe the journey a to m exactly. Alright, so let's do that. I'm going to write down a to m now, and I'm going to describe the journey exactly. So, here we go. K is equal to 4/3, so 3 halves times by 4/3 is going to be 12 sixes or 2a. So we've got two lots of a's, direction vectors. Okay, 3 over 2k, and I know k is equal to 4/3. 4/3 times by 3 over 2 is equal to 12 over 6. 12 over 6 is 2, so I can write down 2a. And I know that 3/4 times by 4/3 is going to be 1. So that's it. A to m is the vector 2a plus b. And I know that a to p were all given at the beginning of the question, just below what I'm writing now. Okay, was 1.5a plus 3/4 b. And that's reassuring that we got it right because they're obviously in the same direction. But they're asking us for the ratio, aren't they? So I'm just going to quickly draw it, make sure I've got it right in my head. Okay, so a to m is 2 a's, and a to p is 1.5 a's. So if I can see I've got 3 halves a to p and 1 extra half to get from p to m. So it's a 3 to 1, isn't it? That's the ratio of this line, and that's my answer incidentally. So a to p and p to m is in the ratio 3 to 1. Alright, so let's see how we did. I'll definitely pause here, and yeah, it was a challenging question, and I hope they've given us more than 4 marks, because I think that was pretty tough. We had a lot to do. And if we have a quick look at the mark scheme, 3 to 1, lovely. And I've used the first method, I believe.